If you recall, when we started this section, we defined the terms, defined what a polynomial meant. And one of the restrictions of a polynomial was that it had to have terms that had counting number powers. That means that things like 0 as an exponent or a negative number as an exponent aren't really good forms for the final versions of expressions sometimes. And in fact, we usually want to not have 0 or negative powers as part of our final answer. However, sometimes they come up as we try to follow rules or do things. So they do have a mathematical meaning. Let's talk a little bit about where they come from. If you recall from the last video, we saw where a 0 exponent came up when we did x to the 6th divided by x to the 6th. So in this particular example, what happened was when we went to subtract the powers, so from a written out perspective, all the x's canceled on the top and the bottom, and I was left with just 1. But if I were to use the rules for dividing with exponents, which says you can subtract the powers, if I do x to the 6th minus 6th power, I end up with x to the 0th. And what this really boils down to is that anytime you have any number to the 0th power, it's always equal to 1. It doesn't matter what the base is. We could have x to the 0th power. That's equal to 1, like what we did up here. We could have 5 to the 0th power. That's equal to 1. Or we could even have something as crazy as 2xy to the 5th plus 4. But if that whole group is being taken to the 0th power, doesn't matter what the base is, it's equal to 1. Everything in terms of the base goes away, but it comes back to this idea here that when if I were to set this up and subtract those powers to get 0, everything would cancel out. So that's something that we kind of want to keep in mind when we're dealing with 0 exponents. Now, negative exponents we saw in the last example. So in that problem, we had something like x to the 2nd over x to the 6th. And if we followed the rule for division where you subtract the powers, when we did x to the 2 minus 6, we'd end up with x to the negative 4th power. So we do see negative exponents come up when we follow the rules. However, what does that actually look like? What does x to the 4th mean? Well, you can kind of see what negative exponents mean if you were to write this out and see what happens with the x's. 3, 4, 5, and 6. So in this case, 2 of the x's cancel out with 2 of the x's on the bottom, and what I'm left with is 4 x's, so x to the 4th, but it's located in the denominator of the fraction. So as we go through and do these problems, anytime that you see a negative exponent, what it really means is it's reciprocal. The negative doesn't mean the negative in the power does not mean it's a negative number. The negative in the power means that it's going to switch in position between the numerator and the denominator. It has a reciprocal relationship. And remember, reciprocals were where you switch the numerator and the denominator of a fraction. So we end up with this reciprocal relationship, which means that my negative power becomes positive on the other on the other side of the fraction. So the negative power becomes positive if it moves between the numerator and denominator. So, for example, if we have x to the negative 2nd, that becomes x to the positive 2nd if it moves to the denominator. Now, I do need to show that it's a fraction in the denominator, so I do need a numerator, and we always just use 1 if there's nothing else there. In this particular case here, I have 5x being taken to the negative 3rd power, so I can rewrite this expression with a positive power. So the 5x was in parentheses. That whole thing is now going to have a positive 3 power, and it's going to be in the denominator of the fraction. So that's what that negative exponent will do for you. Now, in this particular case, notice that we can simplify this a little bit. We have a group of things being taken to the 3rd power. So we could take 5 to the 3rd power. 5 times 5 times 5 is 125. And we can take x to the 3rd power. And so 5x to the negative 3rd is the same as 1 over 125x to the 3rd. For the next problem here, and this is really important to understand the difference between this one and this one. Notice in problem number 22, the negative exponent was this power was being taken, the negative exponent was being taken to the 3rd power. or the 5x was being taken to the negative third power. In this case, only the x is being taken to the negative third power. Remember that little trick of what's directly in front of the exponent is the only thing that's getting the power. So in this case, only the x is being taken to the negative third, whereas in this problem, all of the 5x is taken to the negative third because the parentheses is what was in front of the exponent. So if I were to rewrite this problem, the x to the third, or x to the negative third, becomes x to the positive third on the bottom. But this 5 stays where it was. It's not being taken to the third power. It didn't have a negative. And if you think of it as 5 over 1, the 5 was in the numerator before. So the 5 stays on the top, and only the x to the third moves to the bottom. And that's the difference there in that particular problem. So that should help a little bit. Now, what happens if you have a negative exponent in the denominator of a fraction? Well, that's why I used the terms reciprocal relationship up here. If it's in the bottom of the fraction, it becomes positive when it moves to the top of the fraction. So we could think of this as y to the third on the top over 1, and that is just y to the third. That works great. Here we have a couple of things. Here we have a negative exponent that only the x is being taken to, and here we have a negative exponent that only the y is being taken to. So the first thing that I like to do when I'm doing these problems is to rewrite this whole fraction with no negative powers. So anything that didn't have a negative exponent stays where it was. Anything that had a negative exponent is going to move its location in the fraction. So for here, I started out with 3 on the top, and then I had x to the negative 3. That becomes positive 3 on the bottom. And then I had a y on the top, so it stays on the top. Now I move to the denominator. There was a 6 in the denominator, so it's still in the denominator. Then I had y to the negative 4th. The negative exponent becomes positive by moving up to the top. So what I have now is this big fraction here, 3y, y to the 4th over 6x to the 3rd. Now, anytime that we have a fraction of any type, we do want to see if we can reduce anything. The 3 and the 6 out in front are just regular fractions, and we can divide the numerator and the denominator by 3. That'll give me 1 on top and 2 on the bottom, and so I end up with that 1/2 there. Now, I also want to only have one of each variable. If there's any way I can put things together, I want to do that. On the top here, I have a y times y to the 4th. Remember, if we're multiplying things with exponents, we add their powers, so that's like adding y to the 1, and y to the 4th gives me y to the 5th power on the top. On the bottom, I just had the x to the 3rd. There's nothing that can combine with. And so my final answer for this, most simplified, would be 1 y to the 5th over 2x to the 3rd. And remember, you can leave ones are optional, and you can kind of leave those out there. And so I could rewrite that just as y to the 5th over 2x to the 3rd, and that would be a good solution for that problem. So only move the parts that have the negative exponent. This is the last type of weird problem that you'll see here. Here we have a negative exponent again. We look at what's in front of the negative exponent and its parentheses. So that means that everything inside here, the 2 over 3x, all needs to be taken to the negative 3rd power. So if I want to rewrite this with no negative exponents, the very first thing that I have to do is find this reciprocal relationship. Now, because I had a fraction to start with, what that means is that what was on the top is now going to be on the bottom, so that's the 2 is going to end up on the bottom, and what was on the bottom is going to end up on the top, so that's 3x. So essentially I find the reciprocal of this whole thing, which is just 3x over 2, and now that will be to the positive 3rd power. So the negative exponent becomes positive by looking at the reciprocal relationship of what was being taken to that power. Now at this point, what we can do is we can take each thing inside to that power. So the 3 can be taken to the 3rd power. 3 times 3 times 3 is 27. The x can be taken to the 3rd power. And then on the bottom, the 2 can be taken to the 3rd power. And 2 times 2 times 2 gives me 8. So this would be my best final solution as I get there. But the key to solving this whole thing was remembering that when you have a negative power, it can become positive by looking at the reciprocal of what was there, and moving that around gets us to our solution.